Hello there, and welcome to another Science Saturday. I'm your host, Noah Mugen. I hope you've had a wonderful end of summer and a nice start to school. We're glad to have you back. Today, we're going to be going over the science of sound, and I'm going to quickly go over the materials that we'll be using. Now, if you don't have all these, don't worry, it's easy to follow along even without them. Today, we'll be using a large bowl, a glass bottle, rubber bands, scissors, string or twine, sugar crystals, a spoon, plastic wrap, paper cups, and water. If you didn't know, I'm in the high school marching band. And so right now, especially in August, music really dominates my life. As such, I got music on the brain. Now there's a quote that I like that says, music is just sound that makes sense. And it's pretty true. But what exactly is sound? Well, that's what we're going to be covering today. Sound isn't like light. Unlike light, sound doesn't have specific particles like photons or anything that make it up. However, there is one important similarity between them. They both travel as waves. At its core, sound is the vibration of a fluid, like air or even water. And those vibrations travel throughout that fluid as waves. When I hit the table or my vocal cords say something, they create waves of kinetic energy that travel through the air. Think of when you drop something in water. When it hits the water, it goes in, and waves will go out from it. That's kind of like how sound works. Tiny eardrums in our ears are able to pick up these tiny vibrations in the air and convert them to information that we can use to learn about our surroundings. This is a process called hearing. You can actually see these vibrations with an experiment using a bowl, plastic wrap, rubber bands, and sugar crystals. First, cover the top of the bowl in plastic wrap. Make sure that it's really taut so that it's not very bendy or loose. And then use rubber band to hold it in place. Now, you're going to carefully get a few sugar crystals in your hand. Make sure not to spill them or make a mess, because I don't think anyone will like that who's going to be sitting at whatever table you're at. And put them on the bowl. Spread them out a little bit. All right, now, what you're going to do is just get really close to the plastic and make a sound. And you should see that the sugar crystals start vibrating. Watch this. Can you see that? Now that's not actually my breath that's moving them. You could do that by just getting like a microphone or a phone and playing something right next to it. It would have the same effect. The reason that the sugar crystals are vibrating is because that the waves of sound coming from your mouth hits the plastic. And since it's held so taut, it lets the vibrations travel into the sugar crystals, which make them start vibrating. The louder you are, the stronger the vibrations are. And so, the more the sugar crystals vibrate. And this actually shows an important attribute of sound, the fact that vibrations can travel through different mediums or substances. The reason that you can hear something on the other side of your bedroom door is that when a sound is made on the other side, the vibrations in the air travel as waves to your door. Your door begins to vibrate in the same way, and the waves travel through it until they reach the air on the other side, at which point the air begins to vibrate in the same way, and then it travels to your ears. You can show this transfer of sound with a tried and true string telephone. For this, you're going to need 2 paper cups, scissors, string, and a willing assistant. First, cut a pretty long piece of string. Enough that 2 people could stand pretty far apart and hold each end. Then poke a hole in the bottom of each cup. You can use your scissors, or if you want, you can use like a pen or something. If you do use a pen, make sure to use the scissors to make the holes a little bigger. And thread the string through each hole. Once you've done that, tie a little knot at the end of each string to make sure that they don't leave the cups. Now grab your partner and have them hold one cup while you hold the other. Stand far back enough so that the string is pretty taut, and have them talk into it while you listen. You should be able to hear them.
Hello?
Hello there. And as you can see, well, I guess you couldn't see, but you gotta trust me, that I heard him much better than if he had just been standing there right next to me. The sound from his vocal cords traveled through this string and back out into the air, where it vibrated my eardrum and I could hear him. And different vibrations will make different sounds. In waves, the frequency of the wave is basically how fast the particles vibrate. It's typically measured as the number of back and forth vibrations in a certain time. And its most common unit of measurement is hertz, which is vibration per second. So, if a wave vibrates, or goes up and down, 150 times per second, then it would have a frequency of 150 hertz. Now, it's important to note that this isn't how fast the wave is moving from point A to point B. All waves will travel the same speed in the same medium. However, if a wave has more energy, it'll be able to vibrate more as it's going along. And as it's vibrating more, that will increase its frequency. So you could say that the frequency of a wave is dependent on the energy. A higher energy contained within a wave will have a higher frequency of the wave. While if a wave doesn't have much energy, it won't vibrate as much, and so its frequency will be much lower. We humans perceive the frequency of sound waves as pitch, basically how high or low it is. A higher frequency will make a sound with a higher pitch, while a lower frequency will make a sound with a lower pitch. For our final experiment, we can demonstrate the relationship between energy, frequency, and pitch. All you'll need: 2 glass bottles, a spoon, and some water. Fill one bottle all the way with water, and put only a little bit of water in the other one. Now, take your spoon and strike them gently to make a sound. You should notice that the glass bottle that has much more water creates a much lower sound. When I hit this bottle with a spoon, I'm transferring kinetic energy into it, which creates vibrations as sound. However, when I hit the bottle with much more water, the water will absorb the energy. As such, the waves will not have as much energy inside of them, and so they will have a lower frequency. In this bottle, there's not nearly as much water to absorb the kinetic energy, and so the frequency can be much higher. That's why we hear this one as a much higher sound compared to this bottle. And that's how sound works. Vibrations pass through the air as waves that we can hear. And waves with higher or lower frequencies will create higher or lower sounds. Well, that about wraps up another Science Saturday. I had fun learning about sound. I hope you did too. Stay safe, have fun, and I'll see you next month. Bye-bye.